Okay, so this next video is explaining the three different gas laws of which an ideal gas would obey. So the first one that we can talk about is Boyle's law. And Boyle's law says that pressure is inversely proportional to volume, only when we're keeping it at a constant temperature. So essentially, if we increase the volume, the pressure is going to do the opposite, it's going to decrease. Okay, and again, if we were plotting this as a graph against pressure against 1 over volume, we would get that linear directly proportional relationship because they are inversely proportional. So if we kind of algebraically wanted to say that if we multiplied the pressure and volume of gas 1, they would equal the pressure and the volume of gas 2. So that's the relationship that we get for them there. Again, making sure we keep temperature constant. For Charles's law, this is our next law that we have. We say that volume is proportional to temperature at a constant pressure. We always have to remember that bit of what we're keeping constant, the relationship between the three. So in this case, again, if I increase the volume, then the temperature increases, or vice versa. If I increase the temperature, the volume is going to increase. So again, if algebraically, if we're wanting to show this, we say volume 1 divided by temperature 1 is equal to the volume of 2 divided by the temperature of 2. Okay, our last law is our pressure law. Okay, and our pressure law, in this case, we have a constant volume, and pressure and temperature are directly proportional. So pressure of 1 over temperature of 1 is equal to the pressure of 2 over the temperature of 2. And again, with this, if I increase the temperature, I increase the pressure. If I increase the pressure, I increase the temperature. So to kind of look at our three laws, if we look at those three relationships there, again, we've got our pressure law, we've got Charles's law, and we've got Boyle's law. Okay, so what we can start doing here is we can start bringing these through and multiplying them through together. And so what we end up with is if we combine these, we end up with P1V1 over T1 is equal to P2V2 over T2, which essentially tells us that pressure, volume, and temperature for an ideal gas essentially are equal to some constant. Okay, the pressure second, volume second, and temperature second, again, is equal to the first. We can say they're equal to the third, they're equal to the fourth. They're always going to be equal to some constant. So we can simplify to say PV over T is equal to some constant there. Now, in terms of trying to relate a constant, we want to sort of talk about in terms of what's happening with the gas. So we start to look at maybe how much gas we have, so how much mass of the gas we have. And so we start looking at it in terms of moles. And what we can say if we have the universal the universal molar gas constant. Okay, so for 1 mole, we can use the molar gas constant, which is given by the symbol R. This is in your data booklets, which is 8.31 joules per mole per Kelvin. So we'd say PV, let me just move that up. PV over T is equal to R. Now, that's for 1 mole of gas, but we might have half a mole, we might have 2 moles, we might have a quarter of the mole. So we have to multiply it by n moles. Okay, so in this case, PV over T is equal to nR. The number of moles is going to remain constant because it's in an enclosed container, and our molar gas constant is a constant there. So we still have our PV over T is equal to nR for the ideal gas that we're looking at. So that brings us to our ideal gas equation. So PV is equal to nRT. Remember, P stands for our pressure. Pressure is measured in pascals. Our volume, okay, is measured in meters cubed. Be really careful with this, especially if you study chemistry, okay, because chemistry sometimes use different units for their volume. So in physics, we're using meters cubed. N, okay, is our number of moles. R, remember, it's a constant. It's in our data booklets, but it's 8.31. And our temperature, this is the big one here. Temperature should always be measured in Kelvin, okay, not degrees Celsius. All right, so if we have it in degrees Celsius, we need to convert it into Kelvin, okay? So making sure that we can do that. The other thing that makes these questions a little bit more challenging is sometimes they don't give you the number of moles. What they might give you is they could give you the number of molecules, or they might give you the mass of the gas, okay? Or they might give you the relative atomic mass of the gas. So we have to sometimes do a further calculation to figure these out. So remember, n being our small n being our number of moles. We've got our number of molecules, okay, being our big N. So that's our number of molecules. So remember, when we're talking about molecules here, it might not just be a single atom. We could have like different types of molecules. So we might be talking about like oxygen, for example. Na, this is our Avogadro's. Our Avogadro's constant. Again, that's in your data booklet. Mass, okay, is the mass of the gas. Be really careful here. This should again usually be given in kilograms, making sure we're keeping that in terms of our kilograms. Usually in our physics questions, they usually give them in there. And our MR, okay, in this case, is actually our molar mass. Okay, so for example, they'll usually give you this in the question. So for example, like helium-42 He, it's going to be our 4 value for that there. Okay, if they give you something like oxygen, which is going to be O2, so our O2 for that, that's going to be like 16, so that's going to be twice, so we're going to have 32 for this one. So looking in terms of our molar mass there for those ones. Something that we might need to calculate and work out.